Okay, so here is our statistics review. Statistics is, it's not quite as exact a science as the other units that we're doing. It's more interpretation based. However, there are better interpretations than others. So we're going to look at different ways of interpreting data. So the first ways that we looked at, we're looking at the mean, median, mode, range, and standard deviation. So what the mean is, it's, think of it as class average. So what you would do is you add up all your data values and then you divide by the number of data values that you have. So for example, if you have 15 people in a class and you have all the marks that they got on their last test, if you added up all those marks and divided it by 15, that would give you out the mean or the class average. The median is the middle data value. So what happens with this one is that you have to rearrange your data from smallest to largest. So once you've got them listed out in a row, the median is the one that falls in the middle. Okay. The mode is the most occurring data. So for example, in that class of 15, let's say 5 kids got 75%, and that was the highest number that was the highest number that was repeated. So in other words, there was no other number that appeared more times than 75%, then the mode would be 75% for that test. Range, what that is if you take your largest data value and you subtract the smallest data value. What you get out is the range. And then the new one that you probably haven't seen before is standard deviation. So standard deviation, what it does is it shows how spread out the data is. So for example, if you have a low standard deviation, then that means that all the data is close to the mean. If you have a high standard deviation, that means that the data is really spread out. So as a teacher, when I'm giving a test, yes, the class average is important, but actually the standard deviation is more important because I want to make sure that all kids are getting about the same mark. To me, that's an indicator that it's a pretty good test. Okay. Whereas if I give a test and the lowest mark was 12% and the highest mark was 100%, those data values are really spread out. So that test would have a really high standard deviation. Whereas if I gave a test and the lowest mark was a 55 and the highest was an 85, that would be a really good test because that would have a low standard deviation. In other words, most kids are getting and understanding that information. Okay, so we used our calculator a lot to find the mean, median, mode, range, and standard deviation. And in fact, all of them can actually be found manually. However, the standard deviation, the way to calculate that one manually, so in other words, not button pushing on the calculator, it's about a 7-step process and it is huge. It takes like an hour to do one question. So we don't want to do things that way. We definitely want to use our calculator. Okay, so there's 2 ways that we can show data. We can show data with frequency and without frequency. So without frequency is where you just list out all your data values. Okay, with frequency is in one of these charts here. So what this means, so if these are test scores, this means that 3 kids got 65% on the test. 5 kids got 74% on the test. 2 kids got 76, and so on and so forth. So if your data has frequency, then we have to plug that data into our calculator in a very specific way. So let's do it first without the frequency. So what we want to do is we want to enter this information into our L1. So we want to enter this into our first list. So the way we do that is we go to a calculator. So what you want to do, so we're in statistics, so you want to hit the stat button. Okay, so to enter in our data, we're just going to hit number 1 for edit. So to clear out anything that might be there, hit the up arrow, hit clear, and then hit the down arrow. Go over, hit clear, hit the down arrow. Okay, so now you're starting with a fresh sheet. So we're just going to put all the data into L1, and it has to go in L1. You can't just pick some random column. So 67, 72, 85. So 67, 72, 85. And then 74, 66, 91. 74, 66, 91. And then the last one was 75. Okay, so once you've got your data entered, then what we want to do is we want to hit Stat again for statistics. And this time we want to calculate. So we want to go over to Calc. And you always are going to pick number 1, always on this menu. Now, depending on what model of calculator you're on, if you're on a TI-83, once you hit number 1, you would just hit Enter. But on my calculator, the TI-84, I'm taken to this menu. So I wanted to look at list 1. I do not have a frequency list, so I'm just going to delete that out. And now I go to calculate. Okay, so this information right here, so let's just bring this over here. So just to kind of tell you what this information means. So this first number that you see, that is the mean. Okay, that's the class average. This number right here, this is the standard deviation. Okay, now if I go back to my calculator, if I hit the down arrow, okay, I'm just going to drag this over. So we have more information here. Okay, so right here, MED, that is the median. Now, right here, I'm told my min and my max. So what I can do for range is I can just subtract them. So 91 minus 66. So 91 minus 66, I get out 25. Now, the only thing that the calculator doesn't give me is the mode. So the mode would be the data value that occurs the most times. When I look at this data set, none of the values are repeated, so there is no mode. Okay, so we've got the mean, the median, the mode, the range, and the standard deviation. Okay, now for the second one here, now we have to enter in a frequency. So when we have frequency data, the frequency has to go in list 2. It always goes in list 2. So make sure that however your data is given to you, you always put the frequency in list 2. And frequency, again, what that means, it just means how many times that data value appeared within your sets. So we're just going to clear that out. So I'm going to hit Stat again. I'm going to go back to number 1. I'm going to hit up, clear, and come down. So I'm just going to drag my screen here just so I can see these values here a little bit easier. Okay, so I'm going to go 65, 74, 76, 80, and 85. Now I'm going to go over to L2. So I hit my right arrow. I'm going to enter my frequencies, 3, 5, 2, 4, and 1. Okay, so now I'm going to hit Stat. I'm going to go over to Calc. I'm going to pick number 1. So my list is in L1, but see now number 2 says frequency list. So I have to get it to say L2. So the way I do that is I go second stat, and I'm just going to pick number 2 for L2. Now the other way to do that, if you don't like doing it that way, is right above the number 2 is the word L2 and it's written in blue. So I can go second number 2, and that's the other way I could do it. Go down to calculate, and there it is. Okay, so again here, just make this a little smaller. So this is my mean. This is my standard deviation. Okay, if I just go down here, hit the down arrow. Whoops. Okay, so right here is my median. From my range, I go 85 minus 65, so my range is 20. And then for mode, mode is the most frequently occurring, so 74 is my mode because it occurred 5 times in the data set. Okay, so do make sure that you know how to do just L1 data versus L1 and L2 data. Okay, so here's another way that I can give you data. So part of statistics is learning how to read graphs. So it says the number of computers sold at a store. So this is frequency right here, and this is the number of computers. So determine the mean and standard deviation for this set of data. So this would be my L1, and these would be my L2. So if I just put this into a chart, so my L1 is 0, 1, 2, 3, 4, 5. My L2 is my frequencies. So 0 computers are sold twice. 1 computer is sold twice. 2 computers is sold 4 times. And then 3 is sold 6, 0, and 1. So again, what you would do is put this into L1, this into L2. When you hit stat, you pick number 1 var stats, and you make sure that you have L1 and you have L2. Okay, and you would go ahead through that process. Okay, so next thing that we looked at was normal distribution of data. So what happens with normal distribution of data is when the data is clustered all around the middle. So for example, this one's kind of normal distributed. If I kind of just did some dots on here, it doesn't quite follow that curve, kind of does, kind of doesn't. Okay, it's that number 4 that's kind of messing things up a little bit. So it's not quite normally distributed, but normally distributed data is where you have the biggest concentration of your data right in the middle, and the further out you go, the less frequency you have. So we refer to these as bell curves because they kind of look like a bell. So where did the mean and the standard deviation go on a bell curve? Well, the mean is always the one in the middle, okay? And then we always go 3 jumps up and 3 jumps down. And how you figure out the numbers that go here is you add the standard deviation to each one of these going up, and then coming down, you minus the standard deviation to get each one of these. Okay, and you never go beyond 3, because usually once we've gone 3 jumps from the mean, that should include darn near 100% of our data. You might have maybe 1 or 2 data values that don't fall within that 3 up, 3 down, and in that case we call those ones outliers. Okay, they're in other words the ones that kind of buck the trend. So the way we show mean usually is with that funky U symbol, and then for this one we would say mean plus 1 standard deviation. This one is shown as mean plus 2, and this one is shown as mean plus 3. This one is shown as mean minus 1 standard deviation, mean minus 2, and mean minus 3. Okay, so if you see those symbols, mean plus 2 standard deviations means just go 2 jumps above the mean. And how you do the jumps is you just add the standard deviation to the mean. Now, what happens is when we do that, we have these general patterns. So if we go 1 jump up and 1 jump down, 68% of our data values should be within that 1 jump range. 95% should be within 2 jumps range, and 99.7% should be within the 3 jumps range. Notice only 0.3% of our data, or those outliers, should be beyond that. Okay, now you don't have to have these numbers memorized. We have a button on our calculator that allows us to find those percentages. We just have to be able to plug in the numbers that go along the x-axis. Okay, so it says if a set of data has a mean of 20 and a standard deviation of 3. Okay, so what would the curve look like? Well, the mean of 20 goes here, and then I'm going to add 3 going up, and then I'm going to minus 3 going down. Okay. So it says, what is the range in values within 68% of the mean? So 68% is within one jump. So that means the range would be 17 to 23. What values are within 95% of the mean? So 95% is 2 jumps out, so 14 to 26. And then if it asks for 99.7%, that would be 3 jumps, so that would be 11 to 29. So whatever that data value represents, that's how you'd find it. Now what Z-score allows us to do is instead of using data values like 11, 17, 29, all that, what we do is we convert everything to a Z-score. So what a Z-score does is it takes our normal curve and it makes our mean value equal to 0. It's almost like a 0 starting point. Like everybody starts at 0. So if you are 1 standard deviation above the mean, the Z-score would be 1.0. If you're 2 standard deviations above the mean, you would have a Z-score of 2.0 because you're 2 jumps above. Or if you're 3 jumps above, you would have a Z-score of 3.0. If you go down, then 1 jump down would have a Z-score of -1, -2, and -3. Now, the reason for having this is, if you think back to one of our last units, do you remember the Best Buys when we were looking at which store had the better deal on ground beef, and one was given to you in pounds and the other one was given to you in kilograms? Well, we had to convert everything to either pounds or everything to kilograms so that we were comparing apples to apples, so to speak. What Z-score allows us to do is that if we convert everything to 0 and then -3 to +3, then we can compare everything equally. The examples we used in class were how you compare to the rest of your class. So for example, let's say in math you're at an 80%, but the class average is 75. So are you above class average? Yes. But you don't know you're 5% above class average. Okay. Whereas in another class, let's say you're at a 92, but the class average is 90. So even though you've got a higher mark, you're only 2 percentage points above the mean. Whereas in my class, in the math class, you are 5% above the mean. So which class are you doing better in? You're actually doing better in the math one compared to the one that you got a 92 in, because everybody in the other class is doing better. Everybody's got a higher average. So when we can, but that's really hard to see with using an 85 and a 92. But if we were to find your Z-score for math and your Z-score for the other class, we could actually compare them and make a really good justification that way. So the formula for Z-scores, how we calculate out Z-scores, is we use this formula. So this is your data value. So this would be like your mark in class. This is the mean or the class average. And then this is your standard deviation. Now remember when you plug this into your calculator, you have to have the top in brackets because you've got 2 numbers in the top. Okay? So it says here, Susie scored 82% on a test. The class average was 68 with a standard deviation of 6. How many standard deviations is she above or below the mean? Okay, so let's just think about this. Let's just estimate first. Now you don't have to estimate, but it's kind of a good idea to kind of get this wrapped around your brain a little bit. So the class average is 68. So if I were to add 6 to each one of these, so if I would go 68 plus 6, because I'm going to add the standard deviation every time. So I'm going to go 68 plus 6 is 74, plus 6 is 80, plus 6 is 86. Okay, so this is 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. Or in other words, this one has a Z-score of 3, a Z-score of 2, a Z-score of 1, and a Z-score of 0. Now she scored 82%. So she's right here. So we can estimate her Z-score to be about 2.2. So in other words, she's about 2.5 or just over 2 jumps above the mean. Now to figure out exactly what her Z-score is, we would just use our formula. So we would go 82 minus 68 divided by 6. And again, make sure you put that in brackets. So 82 minus 68 divided by 6. And we get out 2.33. So we estimated 2.2. Her actual Z-score is 2.33, so she's about 2.3 jumps above the mean. So she's actually doing really good in relation to the rest of the class. Okay, so was that the last of the questions? Sorry, on that? Yes. Okay, so it says use your calculator with z-scores to find the area under the curve. Okay, so if we want to know this, now the reason why we have to use our calculator is right now I know this. If I go one jump out, so if I go from 1 to 1, whoops, from 1 to 1, I know one jump out each way is 68%. But I've gone to negative 1.1 and to 0.9, so I'm not quite at negative 1 and 1. But I'm really close. So if I were to estimate, I would estimate about 68% will be my answer. So how to do this exactly, we use the key normal CDF. So normal CDF. And how we find that key is right here. So I'm just going to clear that out. So I'm going to go second vars. Okay, now notice number 1 says normal PDF and normal 2 says normal CDF. Always make sure you select the normal CDF. So we're going to select that. So my X values are, oops, I selected the wrong one here. So second vars, number 2. Whoops. Okay, why is this not working? Quit out. Okay, so second vars, normal CDF. Okay, so there we go. So it's going to ask you for the lower and the upper. So the lower will always be the one on the left. The upper will always be the one on the right. So I have negative 1.1 on the left, and then the upper is 0.9. Now, because I just have z-scores, remember these are z-scores, so for z-scores, the mean is 0 and the standard deviation is 1. So we can just leave those as 0 and 1. So I get out 68.027. So I get out 68.03%. So I estimated 68%. Turns out it was a very good estimate. Okay? Okay, so on this one, again, mean is 0. I have negative 1.3 here, but it goes on forever. So because it goes on forever, remember this is negative 1, negative 2, negative 3. You just want to put a number here that's really, really small, maybe like negative 1,000. Because we don't have an infinity button, but because technically it does go on for infinity. It'd be pretty cool if we had an infinity button, but we don't. So this is our lower, this is our upper. So you're going to go normal CDF. So you're going to go lower, upper, and then mean and standard deviation. Okay? So again, second vars, we're going to pick number 2. So negative 1,000, negative 1.3, and then 0 and 1 is already done for us. Hit enter. So by the way, on my TI-84, I entered in that menu. If you're doing a TI-83, on your TI-83, you just get prompted with a bracket, so you would just actually enter it in exactly the way it's now appearing on my calculator. So I have to do the extra menu first, but TI-83s get to just go straight to using the commas. So again, to convert that to a percent, you just times it by 100, so we get 9.7%. So 9.7% of our data is within that range. Now similarly here, we're looking for this area. So it goes forever that way. So again, if this is 0, 1, 2, 3, we don't have a positive infinity button, so maybe just use like 1,000. So again, normal CDF. So the lower is negative 0.5, the upper is 1,000. And again, I'm just looking for what percents, right? So I can't use just that 68, 95, and 99 because I'm not perfectly landing on positive or negative 1, 2, or 3. So my calculator allows me to do this without having to estimate everything, because estimating everything takes a while. So I've got negative 0.5, 1,000, 0, 1. So again, if you're running the TI-83, you would just enter it in directly like that. Remember, the comma key is right above the number 7. Okay, hit enter, times it by 100 to get it into percent. So I get out 69.1%. Okay, now we should have been able to estimate that pretty good because here's the thing. Here, this part, I colored in 50% of my curve. So I knew my answer had to be bigger than 50% because I've got this part that's added onto it. So again, when you're doing this on your calculator, you should be looking at the picture to see if the answer seems to be correct based on how you have drawn it. Okay, so again, lower bound, upper bound, okay? So what if we have a problem-solving question? Okay, so it says the average height of a grade 8 child is 142 centimeters with a standard deviation of 12.6. So let's first draw our bell curve. So we've got 142 here. We're going to add 12.6 going up, and we're going to minus 12.6 going down. I'm going to do each one 3 times. So I'm going to go 142 plus 12.6. So I get out 154.6. And I'm going to add 12.6 again. And I get out 167.2. And then one more time, and I get out 179.8. Okay, if I go 142 minus 12.6 now to get the ones that are below the mean, I get 129.4, 116.8, and 104.2. So again, what that means is that 99.7% of the kids in grade 8 should have a height between 104.2 and 179.8 centimeters. So the question is, what percent of 8th graders are between 140 centimeters and 150 centimeters? So 140 centimeters is right about here. Whoops. Actually, let me just do this. So 140 centimeters. So if the average is 142, then 140 would be right about here. And 150 is going to be right about here. So this is what I'm looking for. Now again, if I were to go within one jump, so if I were to go one jump out on either side, that would be 68%. Okay, so I am expecting my, oh, sorry, yes, 68%. So I'm expecting my answer to be smaller than 68% because I haven't even gone one jump out. So again, we're going to use our normal CDF key, but there'll be one little difference this time. So when I use my normal CDF, again, my lower is 140, my upper is 150, but this time for the mean and standard deviation, you don't make it 0 and 1, you have to plug it in based on the values in the question. So we have to make sure and do that. So we're going to go second vars, number 2. So we've got 140 for the lower, 150 for the upper, 142 for the mean, and 12.6 for the standard deviation. So again, TI-83 people, you're going to plug yours in exactly the way it appears here with the commas. Now, if you want to, you can just go times by 100 in this step, and then it automatically shows the percent. So we're expecting 30% of the kids, so 30% of grade 8s should be between 140 and 150 centimeters. And again, it's less than 68, so it's what we were expecting. So for the next one here, how many are taller than 156? So 156 is right about here, and taller is this. Okay? So again, when we do normal CDF, 156. Now, again, we don't have a positive infinity. So I need to come up with a number that's really, really big. Now notice, 179.8 is that third jump out. Going to 1,000 is not enough of a jump. You need to go beyond that. So I'm going to go to like 10,000 or 100,000 even. Okay? So you have to make sure that this number here is a really big number. because we don't have an infinity button on our calculator. So again, second VARs, normal CDF. So it was, I don't remember anymore, 156. So we've got 156, 10,000, and then I've already got the 142 and 12.6 there from the last question. If I times that by 100, I get out 13.3%. Now just to show you here, if I go and change that to only, let's say, 1,000, okay, let's just see what kind of difference it makes to the answer. So it says 13.32. So it doesn't make too much of a difference. In fact, it looks very, very similar, like all the way to 9 decimal places. Just make sure that you're picking a number that represents that positive infinity, okay, so that you go well beyond that third marker. Okay. So the last thing we talked about in this unit was confidence intervals. What confidence intervals are, they're just another way of saying go 2 jumps out on your normal distribution curve. That's essentially what it is. So it says, but there's 3 words that we need you to learn with it. So there's margin of error, confidence level, and confidence interval. You'll typically see these types of questions, whether it be with results from surveys, in political votings. Anytime they're talking about data, they always talk about the survey results. Okay, so in a recent survey, 54% of responders said they would buy a certain brand of toothpaste every time they needed to. This result is accurate to within plus minus 4.2 percentage points 19 times out of 20. So the margin of error, think of this as how much wiggle room you have. So the wiggle room that you have is plus minus 4.2%. So then your confidence interval is applying that wiggle room. So you go 54% is the middle number. It's like your mean. You're going to go add 4.2 and you're going to minus 4.2. So your confidence interval is these 2 numbers. So if you go 54 minus 4.2, you get out 49.8. And if you go 54 plus 4.2, you get 58.2. So your confidence interval is 49.8% to 58.2%. Your confidence level is how confident you are, and it says 19 times out of 20. So if you go 19 divided by 20, that is a 95% confidence. So what does all that mean? Okay, so it means that 95% of the time, so if you were to do this survey again and ask another group of people the exact same question, 95% of the time, so if you did that 100 times, you kept asking different people and you did it 100 times, 95% of those times, you should get an answer between 49.8% and 58.2% of the people recommend that brand of toothpaste. Now, it's not every time, right? Because it's data. Data can change based on people's opinions. Okay, so but 95% confident that you're expecting between 49.8 and 58.2% of the people to recommend that brand of toothpaste or to buy that brand of toothpaste. Okay, so you just need to be familiar with what those 3 words mean and then what that information means once you have calculated it. So that concludes our statistics unit. So make sure that you try the questions in the assignment. And if you have any questions, don't be afraid to ask.